Hey everyone, so here's the solutions to the second review. So the first question on the review is this one. So we're given two triangles that are similar, triangle LMN, which is this top triangle, and triangle RWN are right triangles and are similar. And then it says write a proportion to find LM, and then LM equals this. Now over here on my triangle, I'm going instead of focusing on LM, or I'm going to use X to represent that side length. So right now LM is this length here. Okay, that's where I'm going to put my X, because that's what we're looking for. Okay, and the two triangles are LMN and RWN. Okay. Now again, I like to write it this way because then I could find the corresponding sides. So LM, let's do the proportion. Now this top triangle, I have two measurements for the top triangle, X and 30. There's nothing over here. Okay. So I'm going to put X and 30 on top. And then I need to find out which one of these sides from the other triangle match up with X, because then I can put it underneath here. Well, if you look, X goes from L to M. That's these two letters. And the two letters that are underneath LM are RW. So RW is this side. So I know 8 goes underneath the X. Okay. And then 30 goes from M to N. Okay, let me get a different color. M to N, those are these two letters. The second and the third letter. And underneath M and N is WN. And then WN is these two letters, which has the value of 10. So I better put 10 underneath 30 because, again, those are the corresponding sides. So here's the proportion. And then we just solve that proportion. And again, remember, to solve the proportion, it's easy. Just multiply the two numbers that are across from each other. Use the cross products. 8 times 30. And then you get 240. And then just divide that by 10. And you get 24. So LM equals 24. Done. Okay. So let's move on to the next one. So the next one reads, it says Iris is a biologist and she needs to find the height of a tree. She places a mirror on the ground 42 feet from the base of the tree. She moves back in line with the mirror and the tree until she can see the reflection of the top of the tree in the mirror. If she is 6 feet from the mirror and her eyes are 5.25 feet from the ground, how tall is the tree? Okay, so the mirror problem, remember the mirror problem had this diagram. Okay, always here's the mirror. And then you have one smaller triangle. Now where you put the smaller triangle, it can be on the left or the right side, that really doesn't matter. And then you have a bigger triangle. So over here, I'm going to put Iris, the biologist, over here. Hey everybody, I'm Iris. And then I think the other one was a tree, right? So then the tree is over here. And then I'm going to start putting the numbers in that they give us. Okay? It says she places a mirror 42 feet from the base of the tree. Here's the base. The base just means the bottom of the tree. The base of the tree is there. That's the mirror. So that's 42 feet. And then it says, then she moves back in line with the mirror and the tree. She's 6 feet from the mirror. So here's her and here's the mirror. She's 6 feet from the mirror. And then it says, and her eyes are 5.25 feet from the ground. 5.25. How tall is the tree? So we want to find the height. Okay. And again, remember, using a mirror, this creates similar triangles. It's similar right triangles, actually, where these two angles are congruent to these two angles. Okay. And then it says write a proportion to solve this. So the proportion would look like this. I'm going to take her height, which is 5.25. Underneath, I'm going to put the tree's height, So these two need to match up. Now I could have put them on the second spot. That shouldn't matter. But what matters is these two go together. And then I'm going to take her distance away from the mirror, and then the tree's distance away from the mirror. 42. So I do not get why some students get so caught up with how these are written. It doesn't matter if they're equal, it doesn't matter which one goes first. Equal means they're the same, they're equal. So it doesn't matter if I put her distance, as long as these two are the distance from the mirror and these two are the height of the objects. Okay. But anyway, we just cross multiply these two. So let's see. 5.25 times 42. Oh, you guys can't see that. But anyway, that's what we get. And then divided by 6. And you get 36.75. That would be her height, or the tree's height actually. 36.75 feet. Okay, that's how tall the tree would be, 36 feet. I guess if it's a decimal answer, always round to the nearest tenth. So that would be 36.8. Even if you put 36.7, it would give it to you. Okay. But that's the second one. And then the last one is similar to that. This is a shadow problem, but the diagram is already in there. So you don't, you can go through and read the words if you want. I'm not going to. Mr. Roach is lazy. But realize, here's a triangle. And then here's a triangle. Okay? And yes, they're similar triangles. They're similar right triangles, actually. Because they're similar by angle. Now to solve this is simple. Take the height of the lamppost, put it with the height of the fire hydrant, and then the shadow length of the lamppost, or the street light, I guess it's a street light, with the shadow length of the fire hydrant, 5 feet. Okay? And then cross multiply and divide. 26 times 2.5 divided by 5. So we know the street light would be 13 feet tall. Again, I just cross multiplied these two and divide by 5. Let's move on to the next page.